The global consumer product industry is completely reliant on packaging to contain and distribute their products, so packaging materials are constantly produced in massive amounts to meet this demand. Although renewable bio-based materials are already widespread in the packaging industry, for example the cellulose fibres used in milk cartons, there are still lots of packaging products that use fossil-based plastics, for example the milk carton caps. To build a more sustainable consumer product industry, it's important to keep replacing fossil-based plastics with biodegradable and renewable materials to reduce environmental plastic pollution and carbon dioxide emissions. With these goals in mind, I work with the company Blue Ocean Closures, who produces packaging from cellulose fibers, focusing on packaging closures like bottle caps and jar lids, which are conventionally made out of plastics or metals. This is done with a relatively new dry forming technology, where dry cellulose fiber materials are compressed and shaped under high pressures, in contrast to conventional fiber molding technology, which is done with the fibers in a water suspension. Since we're working with a relatively new and unexplored process, there are a lot of open questions and possibilities for improving process efficiency and product quality. My role in this, in collaboration with the Karlstad University as part of the research school EXACT, is to investigate how the material behaves during production. My research is focused on material characterization and modeling together with the numerical simulation of the production process. Through this, the effect of different shapes and process conditions on product quality can be examined in a simulated environment. This could potentially speed up product development and reduce costs for prototype tooling, in the end making it easier to commercially compete against the non-renewable products currently on the market.